much glucose do I need per day? How much amino acids? How much acetate or ketones? And we could come up with our requirements for these things and think about, oh, should we feed to make those things happen? The problem is that all of these things, how much stuff is in the gut, is gut fill, how much liver energy there is, how much stuff is in the blood, how much body fat there is, all of those things send signals to the brain that regulate appetite and how much the cow eats. Furthermore, they send signals to the brain that regulate the system, send out hormones that affect nutrient partitioning. So how much glucose goes to milk as opposed to body tissues, okay? The brain's controlling some of that stuff. So if we think about the metabolic basis for nutrition, milk production per day is a function of the pull of the gland, how many cells are there and how active are there, and once the cow starts lactating, there's not a lot we can do here, okay? The mammary gland just pulls in nutrients. However, if I short the cow on protein, over time, there's going to be less mammary pull than if I make sure she has enough protein. The second thing is how many nutrients can the cow send to the gland, which is dependent on intake and partitioning. And then finally, how good are you at actually supplying nutrients to the cow in the right time, at the right, in the right amounts. So let's talk about intake and partitioning. First off, feed intake is a function of the mammary demand and diet composition. In the US with the TMR system, if we look at the percent NDF in a diet, 26% is what we typically can say is, that's about the optimal percent fiber in a diet to have maximal feed intake. And when I have maximum feed intake, I'm going to have maximum, close to maximum energy intake, and hopefully then also maximum milk production. Okay, intake can be depressed when we have high forage fiber. Too much fiber, intake is lower. Or if the fiber is poorly digested, intake can also be depressed. At the other end, if I have a lot of starch and it's highly fermented starch, I can depress intake. And if I feed a lot of fat. So predicting intake is only a start. In the US, we strongly recommend that our farmers measure feed intake, and that's important for you too. Of course, it's harder on a pasture system. But trying to monitor, figure out how much the cows are eating is critical for maximizing efficiency and productivity. The second point has to do with partitioning and how diet affects that. Okay, so we need ruminantly fermented starch to give us propionate. Propionate is used in the liver to make glucose. Glucose is a precursor for lactose, which is the major determinant of how much milk a cow produces. Glucose can also be partitioned to body stores. Okay, so when we think, we can say, okay, I need to feed starch to meet that glucose demand of the gland. But I need to remember a couple of things, and that is that starch can affect feed intake. Okay, so starch is less filling than fiber. When I start to feed more starch, the cow can eat more total feed. Okay, because she can only eat so much fiber, but if you feed the starch, it's less filling, it digests faster, it gets out of the system faster, she can eat more. So more starch increases feed intake. However, at the other end, if I feed too much starch and it's too fermentable, I get a lot of liver propionate, which means the liver is in a more positive energy status. And when the liver has a lot of energy available to it, it simply says, I've got enough, quit eating. Okay, so when the liver's really got a lot of energy, it shuts down feed intake. So more liver energy can have a negative effect on feed intake. So I want propionate going to the liver, but what I would love is to have a constant supply of propionate to the liver all day long. I'd love to have that be really constant. What happens in your system? When you feed grain in the parlor 2 times a day, you're getting a big rise, big spike in propionate after the morning feeding, a big spike after the evening milking. That's not consistent at all. Okay, that might be the best way to feed. Okay, I'm not saying that it wouldn't be the best way to feed in your system, but you can't have the most consistent rumen environment doing that. You're not going to have optimal efficiency and maximum production when you do that. So we need to think about ways to get a more consistent rumen environment. The other thing is when we get big spikes in glucose, glucose promotes more blood insulin. Insulin says, hey, let's store some of this stuff in body stores instead of making milk. So we can partition nutrients more toward body stores instead of milk. And not only that, A lot of fermentable starch gives us a lower rumen pH, which gives us more trans fatty acids, which can decrease milk fat production, cause milk fat depression, and we end up putting more of the energy in body stores. So now I want to think just a little bit about putting this, a face to this with some data. This is hypothetical first. Okay, so I'm going to say, let's feed increasing amounts of grain, and let's just have our three different grain sources, barley, wheat, corn, and let's say that dry matter intake is going to be the same, although I'm going to say that, for the corn, because it's fermented slowly, there's a good chance the cows are going to eat more per day when I feed grain and when I feed corn in the parlor twice a day instead of wheat. And because of that, I'm going to also add in here the green line. So I don't know what the response is, but there's a good chance the green line is correct for corn instead of the red line like everybody else. If that's true, what could I expect to happen to milk production? Okay, increasing amounts of grain. Okay, the corn at a higher intake, of course, is going to give you more milk, not a surprise. And when you look at milk income, again, not a surprise. Even though we're spending, I should have said in here, I'm figuring that the corn is more expensive. I put in corn, I think, at 35 cents, and I put in the barley at 20 cents. And I put in the wheat at 25 cents. Okay? So I'm putting in cheaper prices for the other grains. But even though I'm spending more money on my corn, because I'm getting more milk, I can have a greater income over feed costs. And the difference could be $1 or $2 per cow per day. Would a model ever tell me this? Would any computer program ever tell me this? Not really. You need to pay attention to what your cows are telling you if you want to know what happens. Okay, so this is data from Ellenbank. This is a study published last year by Allist and others, and they fed 4 different diets. And maybe some of you have seen this data, but I want to just look at a little piece of it because it helps bear out what I'm going to tell, what I want to say. Okay, so they had a control diet. This was what they called a low pasture allowance, 15 kilograms of pasture dry matter per cow per day. Then they fed wheat in the bale. I'm still getting used to that. I'll just say in the milking parlor. And lucerne hay in the paddock. And they fed that at a ratio of 78 to 22. And they're going to feed different amounts of supplement, from 8 up to 16 kilos of supplement per day. And the ratio is consistently 78 to 22. So at 16 kilos of supplement per day, it was about 13 kilos of wheat at milking, and about 3 kilos of alfalfa, of lucerne in the paddock. The next diet is exactly the same as the first one, but now instead of using wheat, they made a grain mix: half wheat, quarter maize grain, a quarter canola. Third option, they fed a partial mixed ration. So they mixed, instead of feeding the lucerne in the paddock, they mixed most of this grain mix with the lucerne in a feeder wagon. I think they must have made it wet to get it to mix well, and they fed most of that in the paddock 2 times a day, and then a little bit of the grain was fed in the parlor. And then finally, they had another PMR diet, but this time instead of only 15 kilo allowance for the cows, they gave a 25 kilo allowance per day. All groups were fed the same amount of buffers, minerals, and vitamins. And what did they find? Well, I don't want you to read all of these numbers. I simply want to point out that for each one of those diets, they had 8, 12, 14, or 16 kilograms of supplement, which was somewhere on the order of 7 to 13 kilos of grain. Okay, with this being all wheat, these being a mix of half wheat, 1/4 corn, maize, grain, and 1/4 lucerne. If we look at the supplemental hay and the pasture intake together, total forage intake was virtually unresponsive to the amount of grain that was fed. Okay, so the animals all ate about the same amount of forage. They had increasing amounts of dry matter intake that was coming from the grain. So what happened? So energy-corrected milk. When they fed wheat at milking, they saw very little increase in energy-corrected milk.